problem. A piece of wood and a bullet collide midair, and we need to figure out how high the combined system will go. Here's our problem. A piece of wood of mass 0.03 kilograms is dropped from the top of a 100-meter height building. At the same time, a bullet of mass 0.02 kilograms is fired vertically upward with a velocity of 100 meters per second from the ground. The bullet gets embedded in the wood. Then we need to find the maximum height to which the combined system reaches above the top of the building before falling below. We're given these options: 10 meters, 30 meters, 20 meters, or 40 meters. And we're told that G equals 10 meters per second squared. Let's visualize this problem with a diagram. Here's our building, which is 100 meters tall. Initially, we have a piece of wood at the top of the building with a mass of 0.03 kilograms. And at the ground level, we have a bullet with a mass of 0.02 kilograms, which is fired upward with an initial velocity of 100 meters per second. Let's work through this problem step by step. First, we need to write down the equations of motion for both objects before they collide. For the wood, which is dropped from rest from a height of 100 meters, we can write the position as a function of time as y sub w equals 100 minus 1/2 gt squared. Since g is 10 meters per second squared, this becomes 100 minus 5t squared. And the velocity of the wood as a function of time is v sub w equals negative g times t, which is negative 10 times t. For the bullet, which is fired upward from the ground with an initial velocity of 100 meters per second, its position as a function of time is y sub b equals v initial times t minus 1/2 gt squared, which is 100t minus 5t squared meters. And its velocity as a function of time is v sub b equals 100 minus 10t meters per second. To find when and where the collision happens, we need to set the positions equal to each other. So we set y sub w equals y sub b. 100 minus 5t squared equals 100t minus 5t squared. When we simplify this equation, the 5t squared terms cancel out, and we get 100 equals 100t, which means t equals 1 second. Now we can find the height at which the collision occurs by plugging t equals 1 into either position equation. Using the Woods equation, we get y sub c equals 100 minus 5 times 1 squared, which equals 95 meters above the ground. Let's see this collision happening. The wood falls from the top of the building, while the bullet shoots upward from the ground. They meet at a height of 95 meters after 1 second, and the bullet gets embedded in the wood. Now, let's find the velocities of both objects just before collision. For the wood, at t equals 1 second, the velocity is v sub w equals negative 10 times 1, which is negative 10 meters per second. The negative sign means it's moving downward. For the bullet, at t equals 1 second, the velocity is v sub b equals 100 minus 10 times 1, which is 90 meters per second, and it's moving upward. Now, since the bullet gets embedded in the wood, this is a perfectly inelastic collision. So we need to use conservation of momentum to find the velocity of the combined system immediately after the collision. By conservation of momentum, the total momentum before the collision equals the total momentum after the collision. So, the mass of the wood times its velocity plus the mass of the bullet times its velocity equals the combined mass times the new velocity v prime. The combined mass is the sum of the two masses, which is 0.03 plus 0.02, giving us 0.05 kilograms. Now let's plug in all the values. 0.03 times negative 10 plus 0.02 times 90 equals 0.05 times v prime. Simplifying, negative 0.3 plus 1.8 equals 0.05 times v prime. So, v prime equals 1.5 divided by 0.05, which gives us 30 meters per second upward. So, immediately after the collision, the combined system is moving upward at 30 meters per second. Let's see how high it will go. The kinetic energy is 1/2 times the mass times the velocity squared, which is 1/2 times 0.05 times 30 squared. This kinetic energy equals mg delta h, where delta h is the additional height gained. So delta h equals v prime squared divided by 2g, which is 30 squared divided by 2 times 10, giving us 45 meters. Now, the collision occurred at 95 meters, and the system rises an additional 45 meters for a total height of 140 meters. Since the building is 100 meters tall, the system rises 40 meters above the top of the building. So, the maximum height to which the combined system reaches above the top of the building is 40 meters. Looking at our options, the answer is D, 40 meters.